Hello there, Mr. Sutton here, bringing you the IM342 Extra Practice number 4 solutions on quadratic formula. There's a puzzle that goes with this one. Let's go check that out. For the puzzle that goes with this extra practice, we're trying to solve the riddle, what do you call it when somebody spends 20 years in the 24th row of a theater? And to get to the bottom of this one, they've given us 7 different quadratic equations that we need to solve. They recommend using the quadratic formula. Looking at the answer choices, it looks like very few of these are actually factorable anyway. So the idea is we solve these and we find the answer down below and just put the letter of the problem we solved above that answer. All right, so let's go ahead and see how this goes. So here's our first problem. This is the I number 1. There's multiple I problems, but this is the first of those. And this one, we may or may not be able to factor it, but we're going to try quadratic formula for really all the problems on this. So a couple things when you're using this. First, we want to make sure that it's in standard form. So ax squared plus bx plus c equals 0. And this one is in that form, so we're good to go there. And then I'm going to write out my quadratic formula every time. That's going to be the variable, in this case, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I'm not going to repeat that every time, but I am going to write it out on all the future problems here. So going through, b, that's the number next to x, so this is going to be negative 7 up top, plus or minus the square root of negative 7 squared, and I'm always going to use parentheses when I plug in all of these parameters. And then we've got minus 4 times the a value 2 times the c value 5. All over 2 times my a value of 2. So simplifying this, we've got positive 7 up there, plus or minus the square root of 49, and then 4 times 2 times 5, let's see, that's going to be 40, so minus 40, all over 4. 49 minus 40 gives us 9 inside that radical, and the square root of 9 is going to be 3, so that works out well. We now have to do 2 different answers to actually match an answer choice here. We have 7 plus 3 over 4, so 10 over 4, which I can reduce to 5 over 2. And we also have 7 minus 3 over 4, that's 4 over 4, which reduces to 1. So 5 halves and 1, and it looks like I've got that right kind of in the middle here, so I'm going to put the I right above that answer. For this next problem, the first problem n in this set, we're going to again use quadratic formula. So x equals negative b and all the rest of that. And this is already in standard form, so we can just go ahead to plugging things in. So I've got negative b, negative 1 in this case, this is 1x, plus minus square root of 1 squared minus 4 times the a value 2 times the c value negative 6, all over my a value of 2 times 2 there. So I've got negative 1 plus or minus square root of 1 minus 4 times 2, that's negative 8, times negative 6 is plus 48. So we're doing plus 48 in there, all over 2 times 2, which is 4. So that's going to be 49 inside the radical, and square root of 49 is 7, so good for us. And then I get my 2 different answers. Negative 1 plus 7 over 4, that's 6 over 4, which is 3 halves. And then we have negative 1 minus 7, negative 8 then, over 4, which comes out to negative 2 if I reduce that. So 3 halves and negative 2. And I see that, let's see here, this one looks similar, but the signs are wrong. Let me keep looking. Right here, toward the beginning. So that's where I'm going to put the n for this one. For this next problem, we're in standard form already, so let's use our quadratic formula. Plugging stuff in. I've got a b value of negative 2, so we have negative 2 up top, plus or minus square root of negative 2 squared, minus 4 times the a value 3 this time, times the c value of negative 5, all over 2 times my a value of 3. So up top, we've got positive 2, plus or minus square root of 4, and then we have, let's see, negative 4 times 3 times negative 5. I think that comes out to positive 60. All of that over 6, 2 times 3. So that's 64 inside the radical. That's 8 if I square root that. 2 plus 8 is 10. 10 over 6 reduces to 5 over 3. And then 2 minus 8 is negative 6. Over 6 reduces to negative 1. So 5/3 and negative 1. That is right over here toward the end, so put an S in that spot. So far, all of my problems have been factorable. This one, it turns out, is not going to be factorable. You can see that real quick if you try to find two things that multiply to 4 and add up to 7. So we have to use our quadratic formula. So there it is again. W equals all that stuff this time. And we're still in standard form. They haven't given us anything tricky in that respect, so we can just go straight ahead to plugging in. So we've got negative 7 there, just negative 7 up top, plus or minus square root of 7 squared, minus 4 times the a value 1 times the c value 4, all over 2 times 1. So that's negative 7 plus or minus square root of 49. And this will be minus 16 here, all over 2. 49 minus 16 is 33. 33 has no perfect square factors, and it's not a perfect square itself, so that's as good as it's going to get. And then 33, let's see, negative 7 plus or minus that over 2. I see the answer choice right here, so I'm going to put my A, because this is problem A, right in that spot. Here we go with the second problem, number I. So for this one, again, I'm not sure if it's factorable or not, don't care. I'm just going to go to my quadratic formula. It's already in standard form, so let's plug it in. We've got negative 3, that middle 3 for the b value there, plus or minus square root of 3 squared minus 4 times 5 times the c value of negative 3, all over 2 times my a value of 5. So that's negative 3 plus or minus square root of 9. And then negative 4 times 5 is negative 20, times negative 3 gives me positive 60, so plus 60. All over 2 times 5, which is 10. So we've got 69 inside. And I don't think 69 has any perfect square factors that go into it. So this is going to be as good as we get here. Negative 3 plus or minus square root of 69 over 10. And I see that close to the beginning, so that's where my second I is going. Next up, we have problem G, the only one of its kind. And this is the first problem where they've respected us enough to give us something that's not in standard form. We can't use the quadratic formula right away. We have to subtract 2 from both sides first. And now I've got something that's actually in standard form where I'll have the correct things if I plug things in from left to right. So there's my quadratic formula. And that should say x, but whatever, we'll just roll with it. So we've got negative 1 from a b value. Plus or minus square root of negative 1 squared minus 4 times the a value 6 times negative 2, my c value, all over 2 times a value of 6. So this is going to be positive 1 plus or minus square root of 1. And then, let's see, negative 4 times 6 times negative 2. That's positive 48, I believe. All of that over 12. So 1 plus 40 gives us a 49 inside. Square root of that is going to be 7. 1 plus 7 over 12, 8 over 12, reduces to 2/3. And then 1 minus 7 over 12, negative 6 over 12, that's going to be negative 1/2. So 2/3, negative 1/2. I see that right here. So that's going to be where my G goes. Here we go with problem E. To do this one, I'm going to have to subtract the 9y to get it in standard form. So 2y squared minus 9y plus 2 equals 0. And now going to quadratic formula, we have negative 9 plus or minus square root of negative 9 squared minus 4 times a value of 2 times the c value of 2, all over 2 times 2 for the a down there. A lot of 2's. So this is going to be positive 9 plus or minus square root of 81 minus, this comes out to 16, all over 4. 81 minus 16 is 65. That's not a perfect square, and it has no perfect square factors. So this is completely simplified. And we're looking for 9 plus or minus radical 65 over 4. That's the very last thing here, so that's where the E is going. For this problem, which is the third number I, we're already in standard form, so quadratic formula, here we go. So we've got negative 6 plus or minus square root of negative 6 squared minus 4 times the a value 1 times the c value of 4 all over 2 times my a value of 1. So that's going to be positive 6 plus or minus square root of 36 minus, this will be 16 all over 2. 36 minus 16 is 20. Now this radical can get split up to simplify it. Biggest perfect square that goes into that is 4, so 4 times 5. So this is going to be 6 plus or minus 2 radical 5 over 2. And if I reduce everything by 2, I end up with 3 plus or minus 1 radical 5, or just simply radical 5. I don't have to write over 1. I can just leave it as 3 plus or minus root 5. And that's over here on the left side. That's going to give me an I right there. Here we go with the first problem L. This one's already in standard form, so let's use our quadratic formula. T equals negative b and all the rest of that. So we've got negative 4, my b value 4, plus or minus square root of 4 squared, minus 4 times the invisible 1 right here for my a value, times the c value of negative 2, all over 2 times a value of 1. So that's negative 4 plus or minus square root of 16, and then minus 4 times 1 times negative 2, that's a plus 8 in there, all over 2. 16 plus 8 is 24. And 24 is not a perfect square, but it has perfect square factors. I can split that up into 4 and 6. Square root of 4 is 2, so we have negative 4 plus or minus 2 radical 6 over 2. And I can divide both of these things in the numerator by 2. So negative 4 over 2 is going to give me negative 2. Then we have a plus or minus. These 2's are going to cancel, so plus or minus just radical 6. Negative 2 plus or minus radical 6 is the very first thing in my list, so that's where the L is going. For the second problem N, we've already got this in standard form, so let's use our quadratic formula. So we've got negative 10 plus or minus square root of 10 squared minus 4 times the a value 3 times the c value of 5 all over 2 times the a value 3. So that's negative 10 plus or minus square root of 100, and then 4 times 3 times 5, that's going to be 60, so minus 60 all over 6. Moving forward, we have 100 minus 60, which is 40. And then I can split 40 up, even though it's not a perfect square, into 4 times 10. 4 is a perfect square, so the square root of that is 2. And now I can reduce all of these. I'm going to reduce all of these by 2's, because 10, 2, and 6 are all reducible by 2. So this ends up being negative 5 plus or minus 1 radical 10, so I'll just call that plus or minus radical 10, all over 3. And that's what my final answer looks like. Let me see if I can find that down here. I think it's this one right here in the middle, so that's N. On this problem, we're almost in standard form, but I have to subtract this 1 over to the left side before I'm really in standard form, and that's going to make a difference there. So my quadratic formula, there it is. We've got negative 3 plus or minus square root of negative 3 squared minus 4 times the a value 4 times the c value of negative 1, not positive 1, because again we moved that over, and then all over 2 times 4 for the a value. So that's positive 3 on the outside, plus or minus square root of 9, and then this is, let's see, minus means plus, so we have plus 16 all over 8. 9 and 16 adds up to 25, whose square root is 5, so that's helpful. We have then for our two answers, we have 3 plus 5 over 8, so 8 over 8, which is 1. And also 3 minus 5 over 8, that's negative 2 over 8, which reduces to negative 1 over 4. And 1 over 4 are negative, right here, this third one, so that's where the V goes. Our second problem L, this one, we have to put it in standard form first. I'll do that by subtracting the 5d and putting it in between the d squared and the 4. So now quadratic formula, we've got negative 5 plus or minus square root of negative 5 squared minus 4 times 2 times the c value of 4 all over 2 times my a value of 2. So that's going to be positive 5 plus or minus square root of 25. And then 4 times 2 times 4, that is all 32. So minus 32 all over 4. So that's going to be negative 7 inside the radical. And we could make that I or not, but no solution is really where this is heading if you have a negative inside a radical. It's no real solution. So that means that we end up with this no solution one, which is where that L is going. All right, we got a couple problems left. This one, x problem x, is definitely not in standard form. So to put it in that form, I'm going to move everything over to the left side. Let me add the x squared over there. And I'm doing that because I want the x squared to be positive. Otherwise, I would have just moved the 2x over to the right. So moving things to the left, we got positive x squared, a positive 2x that was already there, and now we have to subtract 7 to get that over there. And that all equals 0. So we've got it in standard form. So here's our quadratic formula. We end up with negative 2 plus or minus square root of 2 squared minus 4 times 1 times invisible, or not invisible, c value of negative 7. The invisible was the 1 there. So we have 4 times 1 times negative 7 all over 2 times 1. So that's negative 2. We got plus or minus square root of 4. And then here, this is going to be positive 28 all over 2. 4 plus 28 is 32. And I can split 32 up into 16 and 2. Square root of 16 is 4. Dividing each of these by 2, we end up with negative 1 plus or minus 2 radical 2. And that is right about here, so that's going to be an x right there. And at long last, we come to the final problem, which is the fourth I, so a lot of i's to go around in this one. Let me add the 9y to get it in standard form. So there we go. And now for my quadratic formula, I've got negative 9 plus or minus square root of 9 squared minus 4 times invisible 1 times 9 all over 2 times invisible 1. So we get negative 9 plus or minus square root of 81, and then this is going to be minus 36 all over 2. 81 minus 36 is 45. I can split 45 up into 9 times 5 because 9 is a perfect square. Square root of that is 3. So we have negative 9 plus or minus 3 root 5 over 2, and I can't actually reduce this one anymore at all. So I'm going to have to be okay with that and find that in the answer choices. And I see that one right about here. So that's going to be an I going there. All right, so now we have to solve the puzzle. What do you call it when somebody spends 20 years in the 24th row of a theater? And we don't even have to separate things. It's already kind of separated out for us. Living in exile. Living in exile, like exile where they don't let you spend time with anybody else, but also X is the 24th letter of the alphabet. So that's kind of nifty. Anyway, till next time, Mr. Sutton signing off.